it appears that we're dealing with a quadratic word problem. It's going to be quadratic because instead of the sum of unknowns, we are dealing with the product of unknowns. So let's see. My sister's age is 10 less than 3 times my age. If my age is x, then the sister's age is 10 less than 3 times my age. That's 3x minus 10. And now what else is given is that the product of these two ages is 312. So here is the bad news, here is the good news. So the bad news is we're dealing with a quadratic equation, right? We're going to have 3x squared. The good news is that no one is forcing you. Within a word problem, you can do whatever you want to factor this expression. You can use whatever you want. For me, I'm going to complete the square just because this is what we're learning. So for now, let's just stick with completing the square. It's a good exercise. Again, you are not forced to do it. So we're going to factor out 3. This is how we factor out something that's not there. The multiplication backward should work. So 3 times 10 over 3 will give us 10. So it's 104. Okay. So now half of the linear coefficient. So half of negative 10 over 3. To get the half, we divide by 2, or 2 over 1. And to divide is to multiply by the reciprocal. But at this point, it's really important that you simplify. You do not want to deal with 10 over 6 if you can deal with 5 over 3. Because you might notice we're squaring these things, so it's better to stay with 3 than going up to 36 and so on. Okay, so the complete square is x minus 5 over 3 squared. When we expand that, we're going to get x squared minus 5 over 3x minus 5 over 3x is minus 10 over 3x plus 25 over 9. See, in case of fractions, you need this line. There is so much stuff going on. There is a denominator of 3 here. There is a denominator of 9 here. And then there is a 10 instead of... So it's just too much stuff going on. So have this line. This is our complete square, which means 25 over 9 is what we're going to smuggle in. Which would be, by the way, 100 over 36 if you don't reduce that fraction. Okay. For the smuggling step, 3 times x squared minus 10 over 3x plus 25 over 9 minus 25 over 9 minus 104. And because I kind of see down the road, I know we're going to combine these two. I'm going to interpret 104 right now as 104 divided by 1. Okay. The first 3 gets absorbed into the complete square, which is again x squared minus 10 over 3x plus 25 over 9 is x minus 5 over 3 squared, which is what we have here. And now we combine these two, so we have a negative 25 over 9. And to bring it to the common denominator, we're going to multiply both numerator and denominator by 9. It's 936. So now we're just going to combine these last two numbers. We're subtracting both, which means we're adding the absolute values. So if we add 936 plus 25, 961. So we have x minus 5 over 3 squared minus 961 ninth. Square root of 961 is 31. You don't have to be this detailed, I just want you to have every step. So if a fraction looks like a square divided by a square, then take the square roots and that's the square root. And now we are ready to factor via the difference of squares theorem. So we're going to simplify. Now 26 over 3 cannot be simplified, but 36 over 3 can. It's 12. In a way, we got lucky because this number is so awful. It's already discouraging that it's a fraction, but it's a negative number, so it cannot be the age of a person. So this one is easily ruled out. Usually the toughest part is of that interpretation. Sometimes both answers give rise to a different correct solution. But in this case, we're just going to run with 12. Going back to this table, if my age was 12, oh, that would be nice, then this other age would be 3 times 12 is 36, minus 10 is 26. So we think that they are 12 and 26 years old. The fact that this is 10 less than 3 times 12, that's kind of obvious because that's what we use to come up with 26. But the product of the two should be 312, right? Yep, it's 312. So we think that the younger person is 12 years old, the older person is 26 years old. Thank you for watching.